Hey everybody, this is going to be a video about how to solve inequalities that have one absolute value term involved with them. Um, so in general, the process for solving inequalities with an absolute value term is the same as solving equations with the absolute value term. You just have to remember the one big rule that is kind of different for solving inequalities versus solving equations, which is that if you're solving an inequality, if you multiply or divide the entire inequality by a negative number, you have to flip the sign. The inequality sign flips. So let's look at an example, just a nice simple one first. We want to solve the absolute value of x minus 1 is less than or equal to 3. As usual, this breaks up into two different equations. The first one is just taking what's inside of the absolute value and setting it, or solving it as if the absolute value bars aren't there. X minus 1 is less than or equal to 3. The second equation is taking the negative of what's inside the absolute values and solving it. And this is why it's really important, rather than applying the negative to the other side, to this 3, it's really important because with equations, yeah, you can do that, but with inequalities, you have to be really careful because this inequality over here with that negative on the outside, if I divide through by that negative, this sign has to flip. So let's start by solving the easier side first. X minus 1 is less than or equal to 3. Just add 1 to each side. X is less than or equal to 4. Great. So now for this other side, the second equation, negative x minus 1 is less than or equal to 3. Well, the first thing that I want to do, and you technically could do this without multiplying or dividing by x. Maybe I'll actually do that in a second here just to show why the sign has to flip. But the easiest thing to do would be to divide or multiply through by negative 1 to get rid of the negative on the right-hand side here. But if I do that, since I'm working with an inequality, if I divide through by a negative, multiply or divide by a negative, this inequality sign flips. So this becomes x minus 1 is greater than or equal to negative 3. So divide through by the negative, and the inequality sign flips. So solving this thing out, adding 1 to each side, x is greater than or equal to negative 3 plus 1 is negative 2. So those are the solution intervals. X is less than or equal to 4, and x is greater than or equal to negative 2. So kind of written as a single kind of line of inequalities, negative 2 is less than or equal to x is less than or equal to 4. If we were to ask to write this in interval notation, it would be written this way, bracket negative 2 to 4, bracket, because negative 2 and 4 are being included. So, and just to kind of hammer home why it is that you have to do the flipping this sign, let me show you. There is another way, like I said, there's another way of solving this. Man, that's an awful curly brace. There's another way of solving this that doesn't involve that kind of division, or it wouldn't involve multiplying or dividing by a negative at all. So what if, from this step right here, what if I decided to just distribute this negative first? Then we would get on the left negative x plus 1 is less than or equal to 3. And let's see here, what I might do is I might add x to both sides and subtract 3. So if I was to do that, this is the same as 1 minus 3 is less than or equal to x, right? So I just added x to both sides and I subtracted 3. 1 minus 3 is negative 2. And these are the exact same thing. So, and this is really the reason why you have to flip the sign. It's not some arbitrary rule. It's not some strange black magic that nobody knows why. It really comes down to the fact that multiplication is just addition. And when you try to solve this thing out just using addition, you have to move x to the other side. Since it started off as a negative x, you have to add it to the other side. So that's where the sign flips. The sign isn't actually flipping, it's actually just that you're moving something to the other side. But you're doing it in one big step rather than this one, which involved, let's see, I did it in one step, but there are 3 steps involved to get from here to here. 1, you distribute the negative. 2, you have to add x to each side. 3, you have to subtract 3 from each side, and then you arrive at this solution. And we did that in fewer steps just by doing the multiplication and the division. So, right, there's that. I guess the very last thing that I'll mention is that your solution interval is going to kind of change depending on the original orientation of this sign. Let's see what happens if we solve that exact same inequality, but we flip the original sign. So x minus the absolute value of x minus 1 is greater than or equal to 3. Let's see what happens when we solve this. Well, it breaks into the 2 equations. X minus 1 is greater than or equal to 3, and negative quantity x minus 1 is greater than or equal to 3. In this left equation, just add 1 to each side, so x is greater than or equal to 4. On the left, again, we divide by negative 1, which flips this sign, so it becomes x minus 1 is less than or equal to negative 3, and then adding 1 to each side, x is less than or equal to negative 2. So now, just kind of looking at a number line, and I guess maybe I'll draw out a number line up here to make it really obvious what I'm trying to emphasize here. If here is negative 2, here is 4, we want everything that is between negative 2, including negative 2, to 4. Some texts will use this notation with the square brackets. Probably more common is using the filled in dots or the open dots. So that's what that number line with that solution interval looks like on the number line. What does this solution interval look like on the number line? Well, let's see. We want everything that is less than or equal to negative 2. So that's everything less than or equal to negative 2, and everything that is greater than or equal to positive 4. So that's everything that's greater than or equal to positive 4. So see how when we were solving for the absolute value is less than or equal to 3, we got this sort of closed interval, bounded interval. When we solved it, when we flipped that sign, now it's these unbounded intervals, these huge intervals. Which, by the way, writing this in interval notation would be, this interval is everything from negative infinity up to negative 2, including negative 2. And then that is unioned with the interval from 4 to infinity, which is this one, 4 to infinity. So those are the solutions. If you were worried that maybe we made some mistake in here, what can you do to check your solutions? Well, just pick any numbers inside of these intervals. So this one's nice and easy because there is just sort of one interval. Pick any number that you like in here. The nice convenient one is 0. If you plug in 0 into here, the absolute value of negative 1 is positive 1, and yeah, that's less than or equal to 3. Doesn't guarantee that our solution is correct, but it's a good indicator. You can do the same thing. You can do the same thing down here too. You just have to pick 2 different values, one that is less than or equal to negative 2, or you could choose negative 2 if you wanted, one that is greater than or equal to 4, or you could choose 4. In any case, it should all check out. All right, that's that. Let me know what questions you have. I'll be happy to answer them.